All right, let's take a quick look at actually using our simulation. So you should have, generated a mesh. It's going to look something complicated like that. Once your mesh is done simulating, you can actually create a simulation run. So that's the last thing in this menu on the left side of your screen. Hit the plus sign. Let's call this design one, run a one. And you'll notice, up here, resource estimation, 36 to 86 minutes. That's probably for the case of this relatively simple design, an overestimate. But this is, again, a pretty computationally intensive process to actually simulate what's going on here numerically. So it takes some time to run. So again, I would make sure you got the stuff set up. This is cloud-based stuff, so you can hit start, and if it's at the end of class, you can close this out, and it'll run on the servers on the back end. But if you hit start, that's going to run your simulation. There's nothing really to set up for that. So let's fast forward in time. So let's say you got your simulation run, and not through the magic of having, let's see, multiple computers up here. We can take a look at simulation runs. And so here I've got my simulation run. There's a couple things we can look at here now that are going to be super useful for evaluating how aerodynamic this vehicle is. The first thing down here is the force coefficient plot. This is actually what we are looking for. So if we punched in our data correctly in our result control for that forces and moments coefficient stuff, we should see this funky graph here. And we're actually looking for the steady state values out at the end of this graph. That's going to give us the best estimation of these values. And so here we have the lift coefficient. So lift coefficient about 1 means I don't have a whole lot of lift. If our lift coefficient is positive, my car's going to have a force pulling it up. Or if you got a fancy spoiler that works effectively, maybe that's going to provide a downward lift. But in terms of aerodynamics, what I'm looking for is this drag coefficient. And so here, that 0.78329, kind of go out here, get that very last value. That is the drag coefficient of my vehicle. That is the numerical estimation of how aerodynamic my vehicle is. And of course, we're looking here at trying to make that coefficient as small as possible. Now, if you have this set up and you get a drag coefficient of like 3.7, you probably did something wrong in your setup. You probably got like the direction of your drag backwards, or don't have the right direction of airflow, because a drag coefficient should be a number between 0 and 1. So double check that. And you may have to run additional simulations to get that correct. Now, this lift coefficient is broken up into two parts. Broken up into the forward lift, the front lift, and the rear lift. Where'd that go? Oh, they're both the same in this case. Nope, there it is. And that's how much lift is being provided on the back of the vehicle versus the front of the vehicle. So, useful things to know if you're trying to keep that balance. But for what we're doing, we're going to pay attention to the drag coefficient. So that's how to figure out your drag coefficient. To get pretty pictures, we're going to go over here to where it says solutions field. And once you've post-processed your results, this is where we're going to try and set up a pretty picture of what's going on in our design. And so the first thing I would do is under results, let's get rid of velocity. If you hit results, you have a whole lot of different values that you can select to visualize. And I'm going to work with a scalar value. I want to look at pressure. And so this is going to be the pressure that is building up over my vehicle. Now, I can't see much here, but you can go up here to kind of change the view. Go to results. Let me click pressure here. You may want to change the number of levels of pressure that's being calculated. Now, you'll notice it's it's kind of hard to see inside this cube. So what you might want to do is set up something called a cutting plane. And I want to slice this, in my case, along the Y axis. And that's going to just cut this thing in the middle so I can see what's going on symmetrically in my design. Maybe I want to, let me reduce my min value. Anyways, you can play around with these numbers and kind of get an idea of like the pressure buildup around your vehicle. More pressure tends to mean more resistive force. We want to try to minimize the pressure around the front end of my vehicle. And so if you zoom in, you can kind of see like where pressure is building up. So you can see I got pressure build up here at the front. You know, rotate around, I can see that pressure build up. You know, this is just one way of visualizing the effects of air moving over your vehicle. Another thing you might want to play around with is a particle trace. Let me actually. And you can select parts. You can right-click parts. You can hide parts from this menu. But the particle trace is going to show you the streamlines of air moving over your vehicle. And so what you'll need to do, we want to compute velocity. And these are all settings that you can play around with to try and get a good visualization. Over where it says seeds, these are going to be the points that we're going to visualize. And so if you click pick, I want to pick this front face. That's going to create some little dots. Is going to calculate how airflow is moving over the vehicle. And so you can adjust the space in between those. Maybe 0.1 is better. Try to get a 0.1. Try to get a good representation over that front face. And that's going to show you how air is moving over your vehicle. So that just, it kind of provides a visualization of what's going on with your vehicle. It doesn't necessarily provide you a whole lot of useful information. It'll take a little bit of playing around with it to be able to see what's going on. You can also play around with some of these other things. It's just a matter of getting used to using some of these tools. They're a little bit complicated at first, but SimScale's also got tutorials that can help you utilize some of these different visualization tools. So that's what we're going to do with that simulation, once it finishes running.